There are two main types of nuclear bombs: fission and fusion. Fission refers to the splitting apart of the central part of the atom, the nucleus. Nuclear fusion refers to the collision and fusing together of two or more nucleuses, nuclei. In this video, I'm going to be talking about nuclear fission bombs. Now, the primary thing needed in a nuclear fission bomb are atoms with an unstable nuclei. Unstable meaning that the nucleus of the atom spontaneously splits apart. And when these type of atoms split apart, some of their seeds, called neutrons, come flying out. When these neutrons come flying out, if they happen to hit the nucleus of other atoms, it will as well cause them to be unstable, forcing them to fission, which will then release their own seeds, their own neutrons, which hit the nuclei of other atoms, forcing them to be unstable and split apart, releasing more seeds, and on and on and on. That is called a chain reaction. So in order to create a nuclear bomb, you need a lot of those atoms to fission at about the same time in a small area, which releases huge amounts of energy, which causes the explosion. The problem is that even if you can get an atom to fission, to split apart, which releases its neutrons, they go flying out, the odds of it hitting the nucleus of another atom are extremely low. And the reason that the odds are so low that the seeds that come flying out of the nucleus will actually hit the nucleus of another atom is because atoms aren't always close together. They're spread far apart. So to circumvent that problem, scientists developed what's called the critical mass. A critical mass refers to the amount of atoms that need to be compacted into a volume that would essentially ensure with 100% probability that when one of these unstable atoms fission and their neutrons come flying out, that in fact those seeds will hit the nucleus of another atom, causing it to fission, its seeds flying out, hitting the nucleus of another atom, causing it to be unstable and fission itself, and so on and so on. Again, the chain reaction. If you get this critical mass, the odds are so great that you're going to achieve the chain reaction, that is the necessary events in order to take place that will cause the explosion, then you're going to have an explosion wherever you're at. So if you build this critical mass in your laboratory or wherever, you're going to have that explosion right there, in which you do not want. Where you want the explosion is wherever you want to kill the people. So what nuclear physicists will do is create what's called a subcritical mass. That is some amount of atoms shy of a full critical mass. So the final thing that physicists will do is take these two subcritical masses and put them in an enclosure. The enclosure that you normally see as the bomb itself, just a metal casing around these subcritical masses. And inside that casing, on one part of the nuclear bomb, there will be a small explosive. And when this explosive goes off, it's not powerful enough to damage the atom whatsoever. All it will do is propel this half the critical mass into the larger portion of the critical mass. And when it becomes that one full critical mass, the amount needed to cause an explosion, at that point, the explosion will happen. So they'll keep these subcritical masses apart from each other inside the bomb. They'll take the bomb to the location to where they want to cause a destruction. They'll set off the smaller explosion, again, which will propel this into the full, and make it a full critical mass. And at that point, the huge nuclear fission bomb will erupt. So now, when that explosion does occur, what is happening, as I said, is the nucleus of those respective atoms will split apart, causing the seeds of those nuclei to come out, hitting the nucleus of other atoms and causing a chain reaction. And also when this happens, when the atoms are split apart, energy comes out in the form of gamma rays and other energy. And that is what causes the explosion. That is what causes the massive heat that is associated with the nuclear bombs. Now, there's one thing that I still haven't talked about nuclear bombs. Yes, I've talked about that when the nucleus fissions, that the seeds come flying out, the neutrons. But what about the fragments themselves? What kind of damage can they do? These are responsible for what's called the nuclear fallout. That is, beyond the blast of the actual nuclear bomb, radiation goes out. That radiation is these fragments flying out in every direction. If one of these fragments happens to hit one of your cells, it can inevitably cause cancer. If enough of these fragments hit enough of your cells in a short period of time, it can cause death almost instantaneously. And this nuclear fallout, that is the amount of people that are killed by the radiation that's beyond the blast area of the bomb itself, it can cause an additional thousands or even millions of deaths. And that's how a nuclear bomb works.